Yeah, so it's come on now, and then we'll get back to finishing off our bar chart questions, and then we'll go in on to line graphs. Okay. Get that to it. Okay. On current. Okay. So we did the answers here. Okay, here's another one. Here's another question for you to have a go at. Chloe has created a bar chart using the information in the frequency table below. Has she made any mistakes? Look at it, circle the mistakes, and then tell me what the correction should be.
On the third one, it's 2 instead of 3.
Okay.
And then on red it's 5, but it's 36.
Okay, let's have a look.
Mm-hmm.
Yes, you're correct. Yes, correct. And I think you all got the mistakes. I think you should have all got the mistakes. Okay, here's some extension questions. Which number was thrown most often? How many times was the dice thrown? If you get a prize of 50p every time you throw a number greater than 4, how much money would you have after these throws? These are challenging questions. They're sort of moving on towards like level 2 style questions. So it's a crossover between level 1 and level 2.
How much money would you have?
Just like
time.
About 3 minutes just to go over both of them, see what answers you get, and then we'll go through it. Then we'll go through the questions. Okay, let's go through the answers. So which number was thrown most often? Well, you can see here that 2 was thrown most often. How many times was the dice thrown? So let's look at 2. So it looks like if we move it across, it was 7. How many times was it? Oh, sorry, I've misread the question. How many times was the dice thrown? So it was thrown 3 times there, 7 times there for that number. For the number 3, it was thrown 5 times, twice, 4 times, and twice. And if you add them all up together, 23. So it's quite easy to misread the question. How many times was the dice thrown? I misread it as going from the previous question. So be careful there. If you get a prize of 50p every time you throw a number greater than 4, how much money would you have after these throws? This happens 6 times. So if you look at it, 5, 4, 6, 2. So 4 plus 2 gives you 6 times. 6 times 50p, £3. Greater than. So remember the language of maths, greater than 4. So 5 and 6 are greater than 4. So you do not include 4. And you just read off the information. True or false? Girls' favourite subject is maths. True, as you can see. Girls are in blue, boys are in red, and you can see girls like maths the most. More boys than girls choose science. So let's look at science. Yes, we can see that. True, more boys choose science than girls. Maths is the most popular subject in the class. No, because you can see if you add those up together, that's 7 and 3 is 10. But 5 and 6 is 11. So it looks like French is the most popular. French is the most popular. How many girls are there? So we're adding them all up together. 23. So you're adding 3 plus 2 plus 7 plus 5 plus 4 plus 2 should give you 23. And how many students chose other? Well, that's 2 plus 1. 3 students chose other. So this will give you the answers to the questions, therefore extension. Okay, let's look at this one. So different football clubs have different attendances. This graph shows the average attendance for each club. So there's the average attendance for each club. Okay, approximately how many people watched Swansea?
Teacher, please check the recording is not working.
Is the recording not working?
Yeah.
Okay, let's have a look. Let's go. Yes, it is. It's on. The recording is on.
Okay. But
Okay.
my laptop is still not working.
Oh no, it is recording. It may be something happening with your internet connection, but it is recording, Yasir.
Okay, no problem.
Okay, it is recording. Let's go back to the slideshow. Okay, right. Okay, so this is one that you can do afterwards. So it says different football clubs have different attendances. This graph shows the average attendance for each club. So approximately how many people watch Swansea? So if we look at Swansea and go across, we should see that it's approximately 7,900. How many more people watch Bristol City than Brighton? Well, Bristol City looks about 8,005, but it looks about 9,000. Brighton looks about 5,900. And if we reveal it, it should be about approximately 2,800. So we're just doing approximations here. And then which club has about 7,300 watching them? So 7,300. Barnsley. So if we look there. And then how many people watch Torquay? So we're looking about 1,900. Oh, approximately 1,800. Okay. So to finally finish off this part of the topic of bar charts, have a go at answering the following question. Sophie asks the students in her class how they travel to school. The bar chart shows some information results for everyone in Sophie's class. Complete Sophie's bar chart. So can you complete Sophie's bar chart? 2 marks. So you get a question like this in your exam. And this might be on the non-calculator paper.
7 students travel with the bus. 7 students. 4 plus 7 plus 6 plus 10.
So we should have got. Oh, sorry. The
20.
there. So now for my friend. So we should have got 4 for the car. And we should have got for the bus. Now I'm doing this freehand. Normally you'd have your pencil and your ruler and you would draw this neatly. So we should have something like that. So if you've got something like that, give yourself 2 marks. Give yourself 2 marks. So hopefully on the exam paper, your data handling questions should be straightforward. How many students in Sophie's class cycle to school? So from your drawing, you should be able to tell how many students cycle to school. You can tell from your drawing that you've just done of your bar chart, the method had the greatest number of students travelling and the total number of students asked. How many students did she ask? And that will be a total of 5 marks if you got all this. So straight away you should be able to answer those answers quickly, and we should have got 6, walking, and 27. So if you've got all that right, you've got a full 5 marks. And if that was on a non-calculator paper, that would be brilliant. 5 marks in total already towards passing your level 1. Okay, so we've finished there. Bar charts, if you remembered from last academic year, and if you've remembered, and if it's all coming back to you from your previous studies with your tutor with your level 1, again, choose the emoji where you feel you're at now with bar charts. And then remember, you've got your worksheets whereby there's no the worksheets that do not have answers to them. Have a go at doing those worksheets, get them done. Either scan them, make sure you write on the worksheets itself, scan it and send it to me to be marked, or leave it at reception. So then I can know how you're getting on with bar charts and pictograms.
Teacher, this one paper fill and send to the reception.
Let's have a look.
This worksheet.
Yes, yes. Hi, Chloe's Charlotte's daughter, who looks like Charlotte. Yeah, so the worksheets where there are no answers provided, you need to complete those worksheets and hand them back. Okay. Are you understanding bar charts, young lady?
She's trying. She's not allowed to go to school because somebody tested positive in her class, so she's not allowed back until Friday.
Oh, right.
So she just won't leave alone.
Oh, well, at least she's doing some maths.
Yeah.
Okay, let's get back to the next lesson. Okay, the last and final lesson is all about line graphs, and I think we did this again last year. I'm not sure. Did I do it with the end? Did I do line graphs with you, Charlotte, last academic year?
I think so. Yeah.
Yeah. So you must have done it because I said it was to get you ready for level 1. Okay, so let's look at drawing and interpreting line graphs. Right, so our learning objective is to be able to plot information on a line graph and interpret the data using a line graph. So this is another way of presenting information. So line graphs. So what are line graphs? They're used to show direction, change in direction, and they tell us what happens over a period of time. And when we're looking at line graphs and it tells what information is happening over a period of time, we call this a trend. Now, this trend information becomes more clearer when you go on to doing GCSE, and where we're looking at trends, where we're looking at time series, where we're looking at drawing more straight line graphs and trying to work out gradients, etc. Right, so to start a line graph, we do exactly the same thing. We have now our X and our Y axis. We have 0 always as our origin, and then we always use our lines, you know, the spacings between the graph, where we space it equally on both sides. Where it's different from a bar chart, we do not put our labels in between. We put our numbers or our labels exactly where the line is. So you can see 50 is under that line, 100 is under that line, 150 is under that line, etc. So we do not put it in between. That's the difference between your bar charts and your line graph. So let's have a look at an example. School children in the workforce. So we've got our 0, which tells us on the side, the frequency tells us the number of students. So we don't put frequency this time. We write down on the y-axis exactly what we are measuring. And on the y-axis, we're measuring the number of students. So the total number of students was 350, and we're spacing it out. We're looking at it over the period of time from January to July. Now you can actually put your January there onto the 0 point there, or you could, if you want to space it out, put it there, January, February, March, April, May, June. But you've got to be consistent, and that would be 0 there, 0 month. And here you can see that in January, 250 students were in the workforce. February, 250. In March, just slightly above, which would have been 251. Again, about 252. And as you can see, the trend is as you're moving over the period of time, the number of students increases. So this gives us some information about what's happening over a period of time. You have your title. You do your labels. And you always use a correct scale. Always use a correct scale. So that's slightly different from, this is a lot different from your bar charts. So, doing a line graph, you have to be, very, very accurate. And when you're plotting your data, you either put points or crosses. Now, I recommend that you always put a cross. I always recommend, let's get the scale, let's get the diagram in, that you do a cross. The reason being is that when you're using your ruler to draw, you're lining up easily. You're lining up easily, drawing with your ruler. You're lining up between where it crosses over the points there with your ruler when you're plotting the line. And you always draw your line through your points or your X's. If you're going on to GCSE, the recommendation is to draw crosses and not dots. But for the level 1, dots or crosses is okay for now, but the recommendation is that you start practicing using crosses so that it becomes a norm for you. Okay, right. You will get information in this format. So you've got your day, your temperature, and that's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And you can see that on the vertical axis, I've said it's temperature because this is what we're recording. That's what changes. On the x-axis, the days of the week, Monday to Saturday, this doesn't change because you will always have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So your x-axis must always be the one that doesn't change. Your vertical axis is the one that changes over a period of time, which is your temperature always changes. The days do not. You then plot, and as you can see, the 20 is on the line, the 18 is on the line, the 16 is on the line. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday are all written on the line. And now we're going to plot our data. So we've got Monday, which is 19 degrees. So 19 degrees is about here. So we put the x-axis there, so that's when we're plotting. Tuesday is 20, so we put the x-axis. Can you see that I'm putting my x-axis between the cross, between the cross on the graph paper? Wednesday is 17, so there's our Wednesday. 17 is about here. Thursday is 18, so that's going to be here. Friday is 16, so that's going to be here. Saturday is 15, so that's going to be here. Sunday is 10, and that's going to be here. So I've plotted my points. It's now left for me to draw up my points. Now I'm doing this freehand. You would have your ruler. Oops. There. 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 Okay. Oh, that's not too bad, freehand. But you would have a ruler. Okay, you'd have a ruler to draw it. And therefore, you can make some, you know, you can say some things about it. You can say that Tuesday was the hottest day. Okay, but as the days goes on, the temperature drops. Okay, so the Tuesday was the hottest day, but then as the days go on, the temperature drops. So you can make some, you know, you can see what's happening, and you can make some information about, you can make some conclusions about the information that you see from drawing graphs, drawing your line graphs. Okay, so creating a graph. So here is some information that will need a different type of graph. So this time we timed the journey to our holiday destination, and here are the results. For some reason it's not clicking. Okay, why isn't it clicking? It's not clicking this time for some reason. Hold on, let me come out of it and go back into it again. So this is what you should have see. You see here is some information that needs a different type of graph. So you have the length of time, distance travelled, and you can draw a line graph from this to help you tell you where you were at times like at 10:45. Okay, so let's see if this gives us it. Okay, so let's go back to this from current. Okay. Okay, sorry. Let's go back to it. Okay. So we've got our length of time. There you are. We're drawing our graph. Okay. So normally what you would do, you would draw your, you would plot it. So you'd plot this at 0. Sorry, it's gone. So you'd plot this at 0. You'd plot this at 8. You'd plot this at 9:30, etc. So you'd use that information there, and you'd plot your graph. Now at 10:45, which is here, you could go up, read off, and you could say that you're approximately 64 miles away. So you can use the graph to work out information of where you would be at certain times of the day. So if we look at 11:45, if we go up, we're about 81 miles away at 11:45, about 81 miles away. So you can use your line graph to gather a lot of information. Okay, here's another one. So we have our start time with the temperature was 85 degrees. So you're timing how long it takes for the ice cube to melt. At 2 minutes, it was 78. At 4 minutes, it was 75. At 6 minutes, it was 68. At 8 minutes, it was 65. At 10, it was 63. At 12, was 60. You can then draw a line graph. And here's your line graph. There's your start time. At 2 minutes, 4 minutes, 6 minutes. And you can plot and see how long it took for the temperature to drop from the ice cube. So this is interactive, so you can do this afterwards when I've uploaded the PowerPoint. Here's another way at interpreting graphs. So you can see that the graphs can be seen in different formats. So this is where, you know, this would be if you were in a hospital and you were checking your pulse and they were checking your pulse and they had you doing different exercise, they would plot a graph to see how your pulse rate was affected by the different exercises that you did. So when you did an exercise for 1 minute, your pulse rate was just below 60 beats per minute. But another exercise at 4 minutes, your pulse rate was just above 82 beats per minute. So you could see how your pulse rate is affected over a period of time, Okay, and that's another one. Looking at temperature, how the temperature changes over time in Georgia. So there are different ways of drawing your line graph and how you present the data. So finally, just for you to get the idea, have a go at the task on the next slide. Okay, so question 1. The table below shows daily temperatures for New York City recorded for 6 days in degrees Fahrenheit. Draw a line graph for the data. So just have a go. Give you 3 minutes and then we'll go over it together. Got about 10 minutes left. Sorry. I'm going to start putting the label it up. So we should have got something similar to this. We should have got something similar to this. And if we're talking about describing the trend of the temperature, increases over a period of time. Over a period of time. We can say that the temperature was the lowest on day 3. So you can see that the temperature was the lowest at day 3 and then increased after that. Okay, so you can write certain, you can write a lot of information about the temperature for New York City just by reading the information from the line graph. So you can see a lot of information there. Okay, 2 more questions. So there's your line graph, and you're going to interpret this. And you've got 7 questions. What is the line graph about? What is the business time of day at the store? At what time does the business start to slow down? How many people are in the store when it opens? About how many people are in the store at 2:30 p.m? What was the greatest number of people in the store? And what was the least number of people in the store? So from this graph, there are 7 questions for you to answer. Okay, so I think most of you should have answered the question. I've got through down to question 4. So what is the line graph about? Well, it's about people in the store. What is the busiest time of day at the store? Well, we can see the busiest time with 22 people is 1 p.m. At what time does the business start to slow down? Well, it started to slow down about 3 p.m. You can see that it's dropping there. So we should have
6 p.m.
got 3 p.m.
Timer.
How many people are in the store when it opens? Well, that's when it opens at 10 a.m. and we could see that there were only 2 people there. How many people are in the store at 2:30? So this is 2:30, approximately about 10. Ooh, 11. So between 10 and 11, so at 2:30, yeah, so it's about 10 or 11 people. So if you had 10, don't worry, yeah, you'd have got that right because it's approximate, because, you know, with the lines being quite big. What was the greatest number of people in the store? Yeah, we could see that at 1 p.m. it was 22. And what was the least number of people in the store? 2. 2. It was 2 there. So that's, you know, interpreting graphs, and you'll be, you know, given questions on, you know, graph type questions like this, where you'd have to interpret it and answer the question. So your final question is all about small town teens with cell phones. So have a go at that one. Reading the information off the graph. And so for next week, make sure you have a protractor. Okay, let's see how we get on with this one. Shouldn't take any too long to do. What is a line graph about? Well, it's all about small town teens with cell phones, because it's from the title. So you get the information from the title. What age do teens have the greatest number of cell phones? 19, because that's where 642, so at 19. At what age do teens have the least number of cell phones? So the least number was 13 students. 13 years, not students, 13 years. How many cell phones do 15-year-olds have? So 15, they told you 341. About how many cell phones do 16-and-a-half-year-olds have? Well, 16-and-a-half. So what you're doing, you're going up and you're sort of reading as you go across. Now, mine is not very good because my line's over, but it should be underneath and straight like this. And you would see that it's about 500. What was the greatest number of cell phones at any age? 642. So you can see from 19, that's the highest, so it's 642. And what was the least number of cell phones at any age? 229, which was 13. Okay, so that's your practice. Just to finish off, before we finish, you've got the table showing the number of customers each lunchtime at an ice cream parlour. You're asked to draw a line graph for the data. So this is what you can do after we finish. Okay, that's your preliminary, just for you to make sure. And when you've drawn it, you should get this. You should get this as your answer. And then when you've answered the question, you should come up with the following. You should come up with the following answer. The following answer. And that's for you to do once we finish the lesson. Okay, after we finish the lesson. So that's it for today. I'm going to stop sharing. Put myself back on. Stop the recording.